Hi everyone, this is Yung, your lecturer for this course. In this very short video clip, I will briefly introduce what we are going to learn in this course and what you can do to achieve the most learning outcomes from this course. Hope you can enjoy. First of all, I would like to introduce myself to you. My name is Yung Zhu. You can call me Yung. Also, if you like, you can call my English name. My English name is Michael, which is much easier. And I got my PhD degree in 2005. My major was microelectronics. Later, I came to Cambridge University in UK, continue my research work in microelectronics research area. And then I moved to Australia in 2008. I did some research work in Newcastle University. In 2011, I moved to Griffith University in Australia, and since then I work until now as a senior lecturer in Triple E and mechatronics discipline. Now I would like to introduce learning outcomes in this course. So totally we have 4 learning outcomes. After you complete this course, you should be able to, for the first one, to explain the operation principle. That is the working principle, for example, for a wide range of digital electronic circuits. We are going to learn from very basic circuits, for example, logic gates. We are going to start from very simple one, for example, NOT gate, AND gate, or OR gate. Then we will going to make some other more complex circuits, for example, registers, counters, adders, and so on. The second learning outcome is to design some very useful digital circuits. To do that, you need to learn some fundamental theories. For example, uh, what is digital number theory and Boolean algebra and some logic theorems and logic rules. Also, we are going to introduce kernel map to simplify your circuits. After you know the basic working principles for different digital electronic circuits, and you know the digital theories, then should be able to use the electronic lab equipment to implement your design on breadboard and build and test your electronic circuits. Also, you should be able to undertake laboratory work in a team or individually and to present your lab tasks and results in a written report. Okay, now I would like to introduce the teaching team to you. The teaching team will be helping you in learning this course. And I'm Dr. Yongzhu, and I'm the course convener. I will be in charge of all the lectures and all the tutorials. This is my office room and my phone number, my email address. So if you need any help, you have any questions, just give me a ring or just send me an email. Normally, I will reply your request within 24 hours. This is my web page. If you want to know a little bit more about me, just click this link. You can find more information about my research background and my teaching experience. Also, we have 2 lab demonstrators who will be in charge of all the lab activities, also for some lab report marking. So they are all doctors, so we are lucky. So they are very qualified person to teach you electronics devices and circuits. Okay, trimester schedule. Totally, we have 3 learning activities, which are lectures, labs, and tutorials. For the lectures, it will be all the way from week 1 to week 12. And we have totally 3 modules. First one will be very fundamental digital logic circuits and the theories. Then we are going to learn a little bit more advanced circuit, which called the combinational logic. And module 3, we are going to learn some sequential digital circuits. For example, we are going to learn some memory, some flip-flops. And the last one will be module 4. We are going to discuss some practical considerations and some practical circuits. We are going to introduce FPGA and signal conversion. In week 12, we are going to have guest lecture and revision. The guest lecture will introduce some practical industry experience in the area of digital electronics. The labs and the tutorials will all start from week 2 all the way to the week 12. Also, for the tutorials, we have 4 quizzes there to do some tests to assess your achievement in this course. Okay, weekly schedule. We have one consultation time on Mondays for 1 hour in my office room. If you have any questions, you just drop in my office, and I'm more than happy to help you. For the laboratories, we have 3 laboratory groups. You need to check your timetable, and to find out which group you are in, just go to the lab time in your group. And the tutorials and quizzes will be on Wednesdays from 8 to 9. It is a little bit earlier, just try your best to come on time. And the lectures will be on Fridays. Assessment summary. Assessment, I think, is the most important part in your study of this course. Totally, we have 3 assessment items. The first one is the lab activities and reports. As you know, we have totally 4 lab modules, and each module you need to submit 1 report. The total weighting for all the reports is 50%, and you are supposed to submit your report within 1 week after you finish each module. The second one will be the module quizzes. Totally, we have 4 of them, and total weighting will be 40%. And you should do it in the correct time in the tutorial sessions. In the last assessment item, you are required to write a reflection report on the guest lecture in week 12. The weighting will be 10%, and you have 1 week to finish it. For more information about this assessment, you can refer to Learning at Griffith. So overall, to pass this course, you have to achieve a overall mark of at least 50% to pass this course. Learning resources. To help you learn in this course, I will provide a lot of learning resources. The first one will be textbooks. Totally, we have 2 textbooks. The first one is a required textbook. The name is called Digital Fundamentals. This book is very popular and is used in many universities globally. The hard copy of this book is a little bit expensive. It's roughly $70. But the good news is we do have some free soft copy in the library. So please go there and check. But we only have 3 lessons for that. If we have more than 3 students, that may be a problem. And the lectures will follow this textbook very closely. So it is very highly recommended you to buy one hard copy if possible. The second textbook is a recommended textbook, so you don't have to buy this book. The name is called Electrical Engineering Principles and Applications, which is also a very popular textbook. We also have this soft copy as well in the library, so you can go there and have a look, and this will be a very good reference for your study. The second learning resources will be learning at Griffith, which will be the information center for this course. So basically you can find most information on this website. For example, I will put announcement here. So roughly one announcement per week to announce some important information to the whole class. Also, you can find the course profile here. Also, you can get some information for the teaching staff here. Also, I will put all the lecture notes under this folder. You can check all the lecture notes there, and which will be much helpful for your study. Also, I will put the laboratory menu there, and something else which are related to the laboratory under this folder. Okay. Also, we'll have some self-assessment questions, and you can go there and do your self-assessment. For example, do some multiple choice questions and check your answers. And textbook will be here under the reading folder, and basically this all the information you can find on this website. The last learning resource will be the simulator. To validate your circuit design is correct or not, we need some software to simulate your circuit to see if it's working well or correctly. The software we select is called the Circuit Lab, which is a very easy to use software, and which is a web-based software. So you can do the simulation on any computers. So as long as you have a university email address, so you are free to use it. It's free of charge. The second software is called OCAD PSpace. PSpace is a industry standard software, and it is much powerful. Also, we have some free version for you to use, but this is not a required software. You don't have to use this. But if you want to learn something more, it's highly recommend you to play with this software. Okay, now I would like to talk about something about the lab rules, because the labs are very important. We have to apply some rules to it. The first one will be the lab induction. So at the beginning of the first lab, please show your lab demonstrator 2 lab induction certificates. So this is the requirement from the university for the safety reason. The second one will be the lab report submission. Please submit the soft copy of your lab reports through Turnitin. So please don't copy each other. If you do, I will know. Also, late submission will be penalized, which means if you submit your report 1 day late, which means 10% mark reduction. Also, it is possible to arrange a catch-up lab for you if you missed one lab and want to catch up the missed lab. But you have to have a very strong and reasonable reasons. For example, you have to have the doctor certificate. The last one will be very important. So you are allowed to do the lab tasks in a group of 2 students. So you can talk to each other and discuss some questions with your lab partner. However, each student has to submit your own lab report. You can share the data, that's okay, no problem. But your discussions and explanations must not be the same. Okay, assignments. So assignment questions will be given at the end of each lecture topic. So, and solutions can be found in the textbook as well. Also, we have self-assessment multiple choice questions, and it will be uploaded on Linear at Griffith after each lecture topic. Please do the assignments by yourself and then check the solutions. There will be no marks for the assignments, and you don't have to submit them, but you are encouraged to do them because I will pick up most exam questions from the assignments. Summary. For lectures, most lectures will be on PowerPoint slides, and they will be lecture captured. You are encouraged to take down your lecture notes, which is a good way to engage in the lecture. Lecture contents will follow the textbook very closely, and I recommend you to feel free to ask questions at any time. So I would like to interact with my students in the classroom. For the labs, we have 2 different lab activities. First one will be in the simulation software, which is a circuit lab. Also, we are going to implement your designed circuit on breadboard, which is real circuit testing. The sequence of the lab contents will match the lectures very closely. And you are supposed to submit your lab report online through Turnitin. Okay, at last, I want to give you some tricks and suggestions to achieve the best learning outcomes from this course. You need to attend the lectures and the tutorials as much as you can, and it's better to take lecture notes. Also, it's better to read the textbook and the lab manual before you go to the labs. The last one, you need to do the assignments and the self-assessment even if there is no any marks there. Okay, good luck with your study.